lost it. It's okay. It'll come back at some point. Yay, trig! Woo! So you guys already talked about angles. You talked about sine, cosine, tangent. I think you said secant. No, you said cosecant. Good. Cosecant, secant, cotangent. I talked about unit circle. No one mentioned what trigonometry is based upon, though. I don't think. What kind? What kind? Right triangles. There we go. Put them together. Right triangles. All trigonometry is built upon right triangles. We're going to see a lot of those. So we're going to have solving triangle problems. Something else super important? Not really. Ratio of sides of the HonorsPrecalc. You'll learn about that one. Anyway, that's coming later. But for right now, we got to start off with how to measure these angly things. Question. You've already written down all this stuff at the very beginning of radian and degree measure. I haven't actually measured any of them, right? I've just shown a little theta that stands for them. Oh, come back. But in just a second, I am going to talk about radians and degrees. Does anybody know the difference? The true difference. There is a difference, right? Yeah. Okay, because let's say 90 degrees. Let's do an easy one. 180 degrees. Okay, what is that?
1 pi 3 pi.
Well, like what's it look like? What's a 180 degree angle look like? Straight. It's just a flat line, right? 180 degree turn, right? Okay. But what is it in radians? Oh, someone just said it a second ago and I cut you off. Huh? Pi over pi? No.
2 pi.
No, not 2 pi.
1 pi.
2 pi over 2?
Yeah.
1 pi. Good. 2 pi over 2 or 1 pi. So when we talk about pi, as in pi, as in the Greek letter, as in 180 degrees, we have to think about a calzone, right? Think about it. Right? Oh, you know what a calzone is? What's a calzone? No one? Who does not know what a calzone is? This is so simple.
Oh my gosh.
It's like a stuffed pizza.
It's a pizza sandwich.
Yeah, exactly.
It's a pizza sandwich.
Think of a pizza.
I just fold
it before you cook it. You squish, 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 and then just all the yummy goodness inside. It's a half.
It's so good.
It sounds
good.
Okay, alright, hold on.
I'd like to try it.
This is a really good visual if you guys just get it. Oh my goodness.
Oh, she's got
Yes, I'm pulling up a picture, but you never pull up pictures in front of students without making sure everything's okay. You wouldn't think calzone would be bad, but somebody's stupid.
Get me one of those. Honestly.
That's an okay picture. It's kind of boring though. Oh, this one's good. This one's good.
I mean, yeah.
These are all good. Good thing you guys aren't hungry, right? Okay.
Yo! Shut up and take my money.
Right? It's just goodness. And then there's like really big ones. And then it's just, That's a snake. Don't use that one. But there's spiders on it. Anyway. So that's a calzone, okay? It's half a pizza. Like this is a little baby one. That's kind of lame. But, okay. Like just, you guys, this is so sad. Oh my goodness. All right, we're back.
And we're back.
Why did I say, whenever I say pi, think of calzone? I'm pretending we're from like New York or Chicago right now, okay? Because whenever you say pi in New York or Chicago, what do they think of?
Pizza.
A pizza pie, yeah? But we're not doing a full pizza pie because a pie is only how much of a circle? A half circle. So when I say pie, I mean half circle, I mean calzone. Yeah?
Yeah. We follow.
So,
Now we do.
come on, now you do. But wait, hold on. What is pi as a number?
3.
3,
So why am I saying radians and degrees have to be two very different things? 180 does not equal 3. Right? 180 of something does not equal, okay, 180 degrees does equal, or is equivalent to 3.1415926. But 180 does not equal 3, so they have to be different. True? Okay, we're going to learn in section 401 what the difference is. Besides just memorizing a calzone. Got it? Okay. What instrument that you've used in the past has degrees on it?
Compass.
Close. The other one. Protractor. We'll get back to that too. Alright, you guys have all the important stuff? What do we, ooh, go back.
Oh.
Hold
on.
Wait.
No,
Greek
that's
lesson
not
today,
Greek.
just a little baby one. Okay, come back. So, if you have a positive angle, which way is it going? Counterclockwise or clockwise?
Counterclock.
Counterclockwise, right? He's going up and to the left. Where do we start from? The initial side of any angle is, well, unless it's defined differently. But typically when we're doing angles just in like coordinate axes, x, y planes, initial side is always the positive x-axis. We're measuring up. If it's a positive angle, negative angle means measuring down, right? Vertex is at the origin, the vertex of the angle that is. Already talked about the rotation, already talked about the counterclockwise, clockwise. Ooh, Greek letters. So theta, you've seen that one before, yeah? But are there more? Ooh, look at that. Write down the highlighted ones. Wait, but there are two for each one. How come? They're letters. There's an uppercase and a lowercase, yeah? There's an uppercase and a lowercase, yeah? Why? Why am I showing you these? Well, Greek letters are used in math a lot. Math, physics. Technically going into chemistry too, right? Gamma rays? Okay. Just in general, because remember pre-calculus is pre-everything else, mathematical, scientific in some senses. I figured, yeah, since we're talking about theta, is the introduction of the Greek letter that we're going to be using quite a bit, maybe we should talk about other ones like alpha, beta, gamma, delta. Epsilon, zeta, eta, theta. Iota, kappa, maybe. And we're not just getting you ready for things that you probably should be doing in college. I'm not saying all are equal, I'm just saying most are unequal.
By the way, I always learned the quadratic formula. What's inside the square root, the b squared minus, they call that delta. Why? Yeah, they say that's delta. Then you solve delta, then you have the quadratic formula,
It's
square root
called,
of delta.
is that a discriminant? No.
I don't even know why.
It's called something, I didn't think it was delta though. I mean, technically, no, that doesn't work that much.
Just curiosity.
You should research. We have the internet. Look on Wikipedia, but then only half trust it. Okay, so, you guys have all the important ones?
Yeah, my project's done.
Working on it. Which ones have you seen so far this year? You've seen the delta, you've seen the pi before, right? Anything else? We just saw theta. Sigma you've seen before. Ooh, sequences in series. Alpha and omega, beginning and the end. What? That's the Bible. So these have applications, yeah?
Yeah.
And I'm not saying only the highlighted ones do, a lot of the other ones do as well. But just wanted to let you know that you have them. What was it?
I've never seen that one.
There we go. Now, these are not, oh, this is what I was going to say. These are not to be confused with this. Who's that?
Empty set.
It's an empty set, right? Kind of like a not equal to, there is no solution. This one is an empty set. By empty set, I mean the solution set is this. It's empty. There are no solutions, right? Literally, empty set.
Later in the year, don't we use a big old sigma and then put like, you know,
This one.
yeah.
Repeated addition.
There you go.
It's a series. You guys saw it last year. Not series. Series. Okay. Are we ready?
Almost.
I like
Move.
Mu.
Move. It's move.
You got your name on something. Okay, so
Not just Lucas work.
how about now? You guys are killing me. Okay, so why on earth might we want more than one letter that we can represent angles by? Now pause. Can't X be an angle? Sure, but X is used for all sorts of things. So if we have something else that's a little bit more exciting, we probably should do it. Which of these would be most helpful for angles? Well, obviously theta. Obviously alpha, well maybe not obviously, but alpha and beta are pretty good ones. Gamma, gamma rays, maybe we won't use that for angles, but we could. Delta, we use that in math to mean changing, right? So maybe not that one either, but it's helpful to know. Epsilon kind of has its own stuff too. If we really need something else, we might go ahead and, we might use mu. That's not bad. Lambda is not super bad either. Or sigma. Omega's not bad.
We use the P.
Yeah. Let's go. Alright. What are radians? Now, hold on real quick. Am I showing you what are degrees? Nope, I think I'm pretty much just talking about radians. Why? Okay, go back. Why am I not talking about degrees? What is a degree?
That's a good question, actually.
Yeah, right? Like you use them. What's a degree? Who is he? Oops.
I know, I just noticed. What?
Is that
I
been
just
on?
noticed.
It's been pretty quiet.
I thought my phone was off.
What's a degree? There he is. Right there. Isn't he cool? He's super tiny. He's a degree. Just one. They can't even like show it next to because it's not big enough. If he was like, I don't know, this many, then it'd be like, oh yeah, no big deal. I still don't like the degrees down there, but that's okay. Question. Is a degree super close together? Yes, unless he's really, really long. What? He's super close together unless he's really long. Question. If this was a mile long, how much space would there be? Oh, maybe more than you would think. Right? I only stretched it from one side of the smartboard to the other, not even the whole side because the whole page isn't being taken up. I could stretch it even more. And question, hasn't it gotten a lot farther apart? Interesting. So is a degree like a set measurement? No, because it changes as it extends, right? So it's not a set measurement. What is it? Well, I guess if we were to answer what is a degree,
Give you a ratio.
what am I going to write? 1/180th of a semicircle or 1/360th of a full circle. And what am I talking about? 1/180th of what? 1/360th of the rotation, right? So take whatever rotation you need in order to get there, and then it's 1/180th or it's 1/360th. Isn't it a degree kind of awkward? 1/180th. Why would you split a half circle in 180? Because maybe you should research that one too. Add that to your list. But why split it into 360? Interesting. Maybe because 90s are nice, I suppose. But long story short, a degree. Who is he? Well, his measurement, his distance is different depending on his extension and exactly how far he extends. However, we can say that. Think of what a whole semicircle would be. You can cut that in 180s or cut that in a full circle, in 360s or a semicircle in 180s. But still, degrees are kind of awkward. Now, you're most used to degrees. Why? Because the numbers are nicer.
Yeah.
Right? When you were a little itty-bitty kid, if someone was like, hey, 3.141592, you're like, huh? But say, oh, this is 90, like 9. This is 180, like 2 9s, like 18 with a 0, right? That's easier. 45 degree. This is kind of used in the real world more because it's a lot nicer numbers in some senses, but it's not as practical, to be honest, in calculus or in higher math as radians. It's practical for making things understandable, making angles understandable, but the numbers are awkward. Why are they so big? Radians are way nicer. Because radians talk about, look, theta, and not just any theta, theta in radians, not in degrees. Radians actually deal with the specific circle you have, not just any circle and 180th of the semicircle, or 160th of the full circle. Radians deal specifically with whatever size circle you have. In that, an angle in radians is equal to the measure of the arc length over the measure of the radius. It's the proportion, it's the ratio. It's the ratio of the arc length to the radius. I shouldn't say proportion, I apologize. It's the ratio of the arc length to the radius. Wait, like seriously? Seriously. So if I got, for instance, a piece of string. Should have had it out already. I got distracted this morning. A piece of string and a ruler. And for my little circle up there, if I were to take this little piece of string, I use string because it's flexible. This one, I can't measure the arc length with it unless I like break the nails off. Okay, so string. If some of your moms sew, they have probably like flexible measuring tape, right? If I was to take right there, and then, well, that's a little complicated. Stop. Shh, you're fine. Okay. If I was to measure approximately. What do you guys think? Getting pretty close? We'll say right there. Okay. If I was to measure that in inches, maybe centimeters, let's be more precise. Okay. Now, is this very approximate? Yeah. Okay, remember 12 centimeters, okay? What did I just measure? The arc length. So for this one specifically, I could say theta is approximately 12 centimeters over, now what am I going to measure?
Radius.
Radius. I should have trimmed this. I lost them. Okay. Ready? How many centimeters would this be? Over 10.2. Alright, find me a decimal. Very approximate. What's 12 centimeters over 10.2 centimeters? Wait, don't the centimeters cancel out? So it's dimensionless? What does that mean? It's unitless. It's just a number. Huh. Hmm. What angle would you guys have guessed that was? My ones with unit circle before? Just approximately. I don't even know if they meant it to be a precise one. What does it kind of seem like? Okay, let's say it was 60. Might not be, might be a little bit off, but let's say it was 60. Who is 60 degrees as a radian? Do you remember? Oh, build bridges to get rid of what you don't want. How many degrees? How many degrees go with pi? Remember, calzone, how many degrees? 180, right? Then the degrees cancel. I have pi is measured in radians. Okay, what's 60 times pi divided by 180? Go. Yeah, it'd be pi over 3. Pi over 3. But what is that as a decimal? Good. 60 over 180 is 1/3. Hey, pi over 3, pi over 6, pi over 4, 3 pi over 4, 2 pi over 3. Uh-oh, it's coming. What do we get? 1.04. What? Look, my little experiment says it's about pi over 3. It's pretty stinking close to it. What does pi over 3 mean? It means measure the arc divided by the radius. So what if I was to measure try to measure the entire half circle. Okay, it's gonna be rough. We already measured the radius to be 10.2, right? Okay, so if I was to try to do the entire thing, how did you get? Struggle, it's too long. Okay, let's do theirs, right? There's. It's approximate, true? There's. Wait a minute, I don't want to go the whole way. Can I just go halfway and double it?
Yeah.
Oh, that's right, because that's half pi. That makes sense, because it's only halfway through the half circle. How many centimeters do I have? Half pi, pi over 2. I think that's a thing, right? Let's say 18. What's 18 divided by 10.2? Wait. Double it. What's 18 times 2? 36. What's 36 divided by 10.2? Hey, I didn't do too bad. 3.529. What was it supposed to be? 3.14126 if I did it perfectly. Good. So what is a radian? You ready? If you were to measure the radius, if you were to measure the radius, if you were to bring them off to the side and say, hey, guess what? I'm going to make a special ruler with you as my tick marks. Wait, literally? And if you were to build a ruler off of whatever size that radius is, see how I'm building a ruler? And where did this measure come from again, guys? The radius, right? Okay, you ready? Here we go. If this is a flexible ruler or a flexible measuring tape, and if I folded him around my object, guess where one radius would hit? At one radius. If I kept folding it, guess where 2 radii would hit? At 2 radius. Guess where 3 radii would hit? Right before the half circle. Why? Because that's 3.1515926 radian. So where does radian come from? A radius ruler. Oh, interesting. 1 radian because it's 1 length of the radius. 2 radians because it's 2 length of the radii. Thus, radii. Maybe I should have said radii. So what are you supposed to think of when you think of radius? Radians. Think of radius. Radius. Think of radians. Why? It all comes back to this little formula right here. Let's keep going now. So what is pi?
Lucy?
Yeah.
I remember last year. Oh, there's measurements like pi over 6, pi over 4. What? What's the radius that we're using for that? Are we always using radius equals 1? So we can have that?
Yes.
Pi over 6?
Yes. Because remember, it's a ruler of radii. So whatever the circle is has its own unique radius, but then one of those wrapped around will always be in the same location of the 1 radius. Or the 2 or the 3. Similar with the pi over 3, the pi over 4, the pi over 6. It's a ratio, and ratios like 10 over 5 is the same thing as 2 over 1. But 10 over 5, the numbers are way bigger, but it means the same thing because it reduces to be the same ratio. Same thing here. And 1 pi measure is equivalent to 180 degree measures, right? And in the olden days, pi kind of came from people being like, hey, how far around the circle? Or what's the distance around the circle? And what's the distance across the circle? And pi was gotten from the earliest approximations of measuring around and measuring across and dividing. Why does that make sense? Well, because we were talking about a semicircle or a half circle. But half the distance is half the diameter, which is a radius. So whichever way you look at it, whether you think of all the way around divided by all the way across, or halfway around divided by halfway across, you can imagine it's probably easier to go all the way around and all the way across in the sense of approximating. But people way back were able to get pretty stinking good approximations, and if you didn't know, pi is actually in the Bible. Maybe I'll show you the verse tomorrow. Remember with the tabernacle, there were all sorts of different measurements. It was super particular. And the temple as well. One of the objects was circular and there was a distance given. It was with an approximation, but that's what was culturally acceptable in the time. Pretty nifty. What are you guys looking at? Pi over 6? How am I supposed to remember that? Why is pi over 6 less than or smaller than pi over 4, smaller than pi over 3? Hold on. Do you guys see the fractions? Pi over 6 is how much of a calzone? 1/6. There are 6 pieces, so he's not very big. Pi over 4, how much of the calzone is he? 1/4. Oh, he's a little bit bigger than that one. Pi over 3, oh hey, he's even a bigger slice, right? Pi over 2, he's half. Pi, he's the whole calzone, and 2 pi, hey, I got 2 of them, right? Now hold on, what if I was to ask you something like, where would 3 pi over 4 be? He's not written here. How on earth are you supposed to find him? Think about the calzone, you think about him cutting fourths, you say, hey, guess what? I got 3 of them, so where's the angle? Right there. True? What if I was to give you another one? What if I was to give you something like, I don't know, 4 pi over 3? Ooh, that's rough. Unless you see it as, do you have a whole calzone?
Yeah, and one more.
And, exactly, you have a whole calzone and 1/3 more, so think about it. You have a whole calzone, let's take this one, and you have another 1/3. True? True. So where's 4 pi over 3? Oh, it's right there, of course. Some of you had lots of issues last year trying to locate where these different angles are, but you just have to be able to count by, oops, that's not a 2. You have to be able to count by whatever denominator is being given. Why? Because it's dividing the calzone, right? Either into fourths, or into thirds, or into sixths, or into halves. So if I was to give you something like, we haven't done a 6 yet, let's do 11 pi over 6. What would that be?
1/6 out of the actual pizza.
It's almost a 2 whole ones, but you have 1/6 that's missing. Your little baby cousin stole some or something. So we just say, hey, there's only one little 6 that's missing. Everything else, it's mine. Right? 11 pi over 6, he's over here. Now, are there mathematical ways of looking at this too? Of course there are. So if you think about it with calzones, they can make it a little bit easier. Especially if you're hungry and you want a bigger piece. Now, there are some things we have to talk about, but let's not do that today. Let's go ahead and save that for tomorrow. Let me just say the mathematical way. Mathematical way. How would you think of 3 pi over 4? What else did I give you? 4 pi over 3 and 11 pi over 6. How could you transform them to something that you would recognize a bit more readily? You say, I don't like radians, so I build a bridge, right? I'm going to get degrees, so it goes on top. Wait, I'm going to get degrees, so it goes on top. These are called conversion factors. But what's equivalent to 180 that would get rid of the radian? Oh. And what happens when you multiply? The pi's go away and you get a degree measure you're a lot more familiar with. But maybe if you can think in radians, it'll help. Kiddos, we're going to come back tomorrow and finish 4-1. If you want to start playing with homework, you may. Maybe you should.
What?
Oh, stink! Guys, I forgot we did math. Oh well, those who are left. I forgot to have you trick or treat.
Wow.
Amen. Well, you're at the base. You
mean
calculator?
Yep.
Calculator?
There he is.
Oh, sorry.
If you see the other honors kids, be like, hey, she has treats for your tricking.
Privacy. Privacy done. Humans can
Can you get that into straight?
So like 50%, I'll get 50% of what I got.
No, you have a test correction grade that goes in portfolio, so it's like a note check. So you would have a 55 out of 10 on a note check if you do all the corrections perfectly.
Like
It goes in the
Got like half a
portfolio
point
category, which is 10% of your grade.
I got like half a point wrong.
Yeah, but you still have to do the corrections. Just get them in. It's gonna be easy, right?
When do I have to turn in?
By the end of today. You can do 7th period. You can do it after school.
Don't forget though.
Can you put a reminder in your phone? You come in usually anyway, right?
Huh?
Aren't you gonna come in today to do math anyway?
No, I got practice and training right after this.